All right, so 3 methods. You have to know all of them. Okay, so on an exam, you could be asked solve by elimination or solve by substitution or solve graphical. If it's a multiple choice question, does it matter? Nope. Even if the multiple choice question says solve by elimination, you don't have to listen to the multiple choice question. Say, I can do whatever I want. Multiple choice question. Because it doesn't matter. Like sometimes they're worded that way, but really, it's a multiple choice. Who's going to tell you what to do? You can solve however you want. You could even solve by checking. Right? If it's multiple choice, shh, don't tell anyone I'm telling you this. Okay? If it's multiple choice and they gave you 2 questions and there's like 4 different coordinates, couldn't you just figure it out by plugging in those points and doing the check for each one? Don't tell anyone I told you that.
I already did that.
Right? Totally. Okay, so that's called test wiseness. Right? It's smart. Yeah. So, I mean, but unfortunately the rubber will hit the road on the written response because you will have to show it. And it will say if you solve other means, you will not get any credit. Okay? Yeah. No. Because what we're testing is can you do the algebraic. That's really what's important, okay? All right, so problem solving. The nice thing is we've done this before. We've been working up to this moment. Gentlemen, everything has led to this moment right here. Okay, so what I'd like you to do is I'm going to step back for a second. I'd like you to try and come up with the 2 equations. So read through this. It says the difference between 2 numbers is 9. The larger number is 3 more than twice the smaller number. Find the numbers. We're on page 641. Okay. So for the sake of consistency, can we all make x the larger and y the smaller? Okay. You could have used L and S, but okay. Oops, can't see that. You got them? And usually, each sentence is its own equation. Okay, not always, but often it is. So the difference between 2 numbers is 9, period. Guess what? Is that its own equation? Okay, how can we relate x and y when it says the difference between 2 numbers is 9? Close. X, because it says difference, right? X minus y equals 9. Okay, you also could have done what else, Jayesh? Okay, the second one you did x plus 3 plus y. Okay, it says the larger is 3 more than twice the smaller. Are we missing something? Am I missing? 2y, thank you. Okay, erase it. Now, the first equation, the x minus y equals 9, you could have also done y plus 9. The smaller plus 9 equals x. That would work. Y plus 9 equals x. Or you could have done x minus 9 equals y. The larger number, take away 9, equals the smaller number. Right? There's more than one way to write that first equation. I find the easiest is the difference, x minus y, equals 9. Okay, which method is this equation set up nicely for? Substitution. Let's use substitution. Why is it set up nicely for substitution? Because we have x equals. And we know it's x equals when we read the problem, the larger number is, remember? Usually, be careful of wording, but usually is equals. So larger x is equals 3 more than twice the smaller. Okay, so we're going to sub which one into which one? Second into into 1. The reason why is to review substitution. We know x equals, so I can replace the x, because x is equal to 3 plus 2y. So I can replace that x with 3 plus 2y. Let's do that. So where I see x, I'm going to write 3 plus 2y minus the y equals 9. Does everyone see what I did there? Took this and put it in to the x in the first equation. Got it? Okay, so now what? You solve? Simple algebra? Life is good? 3 plus what? Y equals 9. Now what? Do you know what to do from here? Liars, you know what to do. Subtract 3. Y is 6. Done. Okay, what do we do after we got one of them? We don't celebrate yet. Sub y equals 6 into any equation. So 1 or 2? Seriously? Okay. 2 is way easier. I'm going to do 2. Because it's x equals. I don't have to do any algebra. It's like full on plug and play. You can use, honestly, you can use 1. Right? 6 minus y equals 9. Subtract 6, divide by -1. Got your answer. Okay, what do we get? Something seems off to me. No, that's right. X minus 6 equals 9. Sorry. What does x equal? 15. Okay, and last we need to check. So does 15 minus 6 equal 9? Yes.
But it's just x. 9 to 6.
Yeah, well, yeah. You could, that's essentially using the first equation. So, yeah, you could. And then x, which is 15, has to equal to 3 plus 2 times 6. I know it seems like a pain in the butt right now, but on your test, you're going to really want to do those checks also because it tells you, hey, I got the question right. I should be getting full marks. There should be no and ifs or buts about it. Okay, let's turn the page. Just have to get through this page. Seems easy enough, right? Maybe. All right, we've done a couple of these. So is it okay of me to ask you to make the equations yourself? Because you'll have to be able to do that on your test. Okay, anyone want to volunteer one equation? Michaela, yeah? 2L plus 2W equals 40. That's your perimeter formula of a rectangle. If it was, yeah, fish. Okay, so you have W minus 4. So the width is 4 meters less than the length. So, okay, when before minus L, be careful of less than, because when you have less than, this is actually going to go after what follows. So 4 less than the length would not be 4 minus L. What would it be? L minus 4. So this one's a tricky one because the order of your subtraction matters. Also, you have to think, does this make sense? Because width is usually, well, it should be smaller than the length, right? And so does this setup show that the length is larger than the width? Yes, it does. Okay, so when you have less than, 4 less than something, that minus 4 actually goes at the back. If it was 4 more than, addition doesn't matter. We can go 4 plus or plus L or L plus 4, right? Or whatever, it doesn't matter the order, but with subtraction, order matters. Okay, which method would you guys like to do? Graphical? Let's do graphical. Why not? I mean, substitution is great, but we haven't touched a graphical question in a while. So maybe it's good if we look at one for funsies so that we can review it. What would I do if I want to set this up for graphical? Y equals mx plus b. Who do you want to make your y? You sure? Why would it make sense to do w? Because the equation is already w equals. The second equation is w equals. So let's solve for w. This one is already w equals. Let's get w by itself in the next one. So we're essentially, I'm going to give myself a little legend. I'm going to say x is my length and y is my width. So that when I actually solve my answer, I know which one's which. Okay? So this first equation, we need to make it L equals or w equals? Which one? Again, who is our y? W. So we need w by itself. Okay, first step. We're so used to algebraic methods that like graphical seems like more work, hey? It's funny. I'm so proud of you guys wanting to do substitution instead of using your graphing calculators. Speaks to my heart. Okay. Get w by itself. Subtract 2l. 2w equals negative 2l plus 40. And then divide everyone by 2. Give times. W equals what? Negative L plus 20. Okay, grab your graphing calculators. I know. So painful. How dare I solve graphically? I love you guys. You're so awesome. Okay, so here we go. My first equation we're typing in is what? Go to y equals. Clear what's there? So we had LW minus 4, so instead of L minus 4, you're typing in what? X minus 4. X minus 4. Okay. That goes into y1. Then into y2. What are you typing in? Negative x plus 20. No, you could put 20 minus x. Yeah, you could put x minus 4 and y2. Doesn't matter which one's which. Okay, we need to graph. So we push. Graph. Oh, if your windows are regular, zoom 6, will you see your intersection? No. So I'll just show it how you see it. So what do you have to do if you can't see the intersection? Change the windows. The quick way to do it is do what? Zoom out, which is zoom 3. And this is, I love this part, is like you push zoom 3 and then students are like, Ms. Johnson, it's not working. Why? You have to push enter. I know. You have to push enter. Now you can find your intersection point. What do we do? Second trace, 5, enter, enter, enter. Okay, I get 12 and 8. 12 and 8 as my answer. So this is why we make a little legend for ourselves. Which one is 12? Length or width? Right? See right here the legend I made for myself? Which one's length? And also logically, which one's length? 12. Like the length is the long side. They both start with L. So the length is 12 and the width is 8. And the great thing about solving graphically, if this was multiple choice and I still wanted to do a check, well, I can go 2x plus 2y because it stores the x's and y. That should equal 40. And our length, which was x, so width equals, so y equals my x minus 4. and that's 8, and my y is my length, which is also 8. So we're good. Okay, so you can do your check. All right, was that fun? No? You prefer algebraic, eh? I find it easier, actually. Especially in a word problem where you have to like switch your variables to x and y and blah, blah, blah. Okay, Gary has a total. This is a good question. Read this and come up with your formulas. Yeah. Add up. Okay, which one's x? What's x going to stand for? Okay, so more than just 5. Number of $5 bills. And y will be the number of $10 bills. Okay, so what I'd like you to do is read through this question. Do your best to make your 2 equations. So what's one equation? Can someone offer me equation? Yeah? Okay, so that because x is the number of bills and y is the number of bills, then the number of 5s plus the number of 10s equals 33. Good. Okay, now what? Yeah? Okay, so because 5 stands for the value, $5 times the number of $5 bills plus $10 times the number of $10 bills will give us the value of $260. So those are our 2 equations. Elimination or substitution? Yeah, it's kind of set up nicely for elimination. So let's do elimination. Who do you want to eliminate, x or y? Let me guess. You're going to say x. You guys all love to eliminate x. Okay, multiply the first by 5. And we get 5x plus 5y equals, what's 5 times 33? We can do it. 15, carry the 1, 15 plus 165. Okay. Now, are we going to add or subtract? So this is set up for, the signs are the same. Let's do what? Let's subtract them, or basically what we're going to do is switch the signs so we can add. I'm going to add those little negatives in. So my x can cancel out. I'm left with -5 plus -10. -5y equals -95. Good. And then divide both sides by -5, which equals 19. Okay, so logically, how many x's do we have? If we have 19 $10 bills, what was it? 14. And how did you get that? 33 minus the 19 will give you your x's, so 14. Okay, I'm not going to do our check. I'm going to save time. Is that okay? We should be doing our check. Should I do it? And then you have 5 times 14 plus 10 times 19 has to equal to 260. So that's going to be 70 plus 190, or 260 equals 260. Blah. Do you ever feel that way about your checks? I do. But they're good. They are good. It's like good for you. Okay, really quickly, this question here. Max has 13 coins in his piggy bank. He only has dimes and quarters because his mother is cheap. They spelled cheap wrong. Yes, it's an A. Thank you. She also can't spell. That's better. He has $1.85. How many of each coin does he have? So I wanted to show you quickly this example because you have to be very careful because your currency, is that right? Or the has to be the same. So when I set up my equations, let's use D and Q. What's one of the equations?
0.05.
Okay, well, first D plus Q equals 13. Number of dimes, number of quarters equals 13. What's the second? Would you go 5D? How much is a dime worth? Duh. Would you go 10D plus 25Q equals 185? No. Okay? This is in pennies. This is in dollars. Your value has to be the same. You can make it 185. So pennies, all in pennies. Or how else could you write your equation? 0.1D plus 0.25Q equals $1.85. That seems like a great question on a test. Okay, last question. Oh, great. You can start your homework. Okay. Laura invested. These can show up as well. Why is this? 1 second. Okay, Laura invested her inheritance of $48,000 in 2 different mutual funds. At the end of 1 year, one fund has earned 10.5% interest, and the other earned an average of 12% interest, okay? If she received a total of $5,520 in interest, how much did she invest in each mutual fund? Okay, so let's define the variables together, and then you're going to come up with the equation. Give me one of the variables. Doesn't matter. Okay, X and Y. So X will stand for what? Yeah. Okay, so amount invested at 10.5%. Okay, the first mutual fund, and then what you said Y? Be amount invested in %12. Okie dokie, guys. I'd like you to come up with your 2 equations. It's a little tougher. Little tougher. But give it a shot. See if you can at least try, right? That's what erasers are built for. Making mistakes. It's all good. No. Okay. It might be helpful to make a chart. So you could make a chart for this. You don't have to. I'm just saying if you really struggle with making these formulas. So the first is your percentage. Okay, it goes in the first table. So your percentage at 10.5%. How would you write that percentage? Would you write it as 10.5 or would you change it to a decimal? A decimal. So 0.105 and this would be 0.12. Okay? The second column would be the amount invested. Okay? How much you invested. Okay? So how much did we invest at 10.5%? X. This is always where your variables go. And then the last column is always the product of the 2 because this is the amount earned, money earned. So the amount earned on the 10.5% investment would be 10.5% times the amount you actually invest. The amount earned at 12% would be 12% times how much you invest. And our 2 totals go in the bottom. So how much was it total money invested? 48,000. Okay, and how much was the total amount earned? Money earned total? 5,520. And so here's our 2 formulas. You should have X plus Y equals 48,000 and 0.105X plus 0.12Y equals 5,520. So there's your 2 equations. Okay, which method do you want to use to solve this one? Graphical? Yeah, it's pretty ugly, so let's use graphical. Okay, so in order to get graphical, we have to get what variable by itself? Y. Good. We just need to get through this and then we're done, guys. So first step, subtract X. And the first equation is Y equals So y1 would be, how do you want to write that? Negative x plus 48,000. Okay, there's y1. y2, we need to rearrange. So again, subtract the 0.105x to both sides. And we're left with 0.12y. Guys, this is ugly. Okay, I hate these decimals. They're not very pretty. And then divide everyone by 0.12. Does it come out, does it at least come out as nice decimals or no? Negative 0.105 divided by 0.12. It's okay. So y equals negative 0.875x plus, what's that equal to? Did you already divide it? It was 46,000? Nice. Yeah, perfect. That was nice. Here's our y2. Okay, guys, graph that, find the intersection. Guess what you're going to have to do? Change your windows. How do I know I'm going to have to change my windows? With the y-intercepts. Look how big those y-intercepts are. They're 48,000 big. That's a lot of change. Okay, so when we go to do this, we have negative x plus 48,000. Zooming out, you're going to have to zoom out a lot of times to get to the 48,000. So it's a lot easier to change your windows. And negative 0.875. Let me put the screen up. View. There you go. X plus 46,000. Okay, so everyone get your equations in, and we'll do our intercepts together. Our windows, I mean. Did you got that in? No. The second equation is plus 46,000, right? Okay, so it's right there. Okay, are we good to go? Push windows. What should we put for our, now can we have negative money here? No, so we can go 0 to, how high are you going to go for your x? 50,000? Sure. Let's try 50,000, and a scale of 5,000 is a nice number. Oops. And y minimum, again, you can't have negative, so 0 to 50,000. Scale of 5,000. Do I need to make this the contrast greater? Is it hard to read, the board at the back? Yeah? No? Yes? No? I changed the contrast when we watched the movie, and so it's a little bit brighter. Not as easy to read from the back, maybe. Okay, if you push graph, can you see the two graphs now? Look how nice that is. It's beautiful. Okay, second trace. 5, enter, enter, enter. 16,000 and 32,000. Do you see why it's really important to define your variables? If I didn't define which variable stands for what, it's hard to know which one was at 10.5% and which one was at 12%. Right? I mean, you could look at your formula and kind of figure it out, but it's nice to have the definition of what each variable stands for, because when you write your sentence at the end, which you should do, it's a lot easier to say which one's which. So how much was invested at 10.5%? Good. So 16,000 was invested. why do you think she split it up between like 2 mutual funds? What would be like an actual real, like, looking at this, be like, why didn't she put all her money at 12%, right? Why would be a reason that you would do that? Yeah.
So if one of those mutual funds fails, you don't lose all your money again.
Okay, that's one good reason. Okay, what else? So like, sometimes if you put all your eggs in one basket, especially if it's a risky venture. That's something. Okay, another reason is sometimes you're locked in. So when you put in money in for investment, they might say that you can't touch it for 5 years or 10 years or a certain amount of time. And so maybe the one that 12% she can't touch for longer, but you might want to be able to access it at some point, right? So you might put it in a lower percentage if you want to be able to access the money sooner. That's another reason when you invest money. So I don't know, you'll get there. Some of you might have already started investing. Anyone? No? Even like stocks or, yeah? Well, I did. I invested when I was at your age and I lost it all. Don't go for a risky one. Go for something safe. I learned the hard way.